First of all, in an acetal formation, there always has to be two equivalents of the alcohol to make the acetal. This means that the hemiacetal mechanism has to happen 2 times. Once the hemiacetal has formed, the only way to convert the hemiacetal to an acetal would be to use an acid catalyst, which drives the reaction to form the acetal product. Also, an important thing to remember is that reactants are always favored. Let's look at an example. First, you start with an aldehyde or ketone, in this case an aldehyde. It will react to an excess of sulfuric acid, which is a very strong acid. The oxygen will protonate the hydrogen, resulting in this. From here, you will take an alcohol, which will attack at the carbon center because that carbon is very electrophilic because of its formal positive charge. That will leave you with this, which now will react to grab the hydrogen proton to result in the hemiacetal. This will react with the second equivalent of sulfuric acid and will protonate its hydrogen. The hemiacetal will form this, and the first thing to note is the water is a good leaving group. So that will leave and the pi bond will be created. Now there is a carbon joined to the pi bond with a formal positive charge on the oxygen. This will be the same as before and react to the alcohol in the same way. This is an important intermediate and called an oxonium ion, which is simply defined as an oxygen with 3 bonds and a formal positive charge. Once reacted with the alcohol, it will form this, and will react with the conjugate base of sulfuric acid. The negative charge will grab the hydrogen and neutralize the oxygen. The final product looks like this, with a carbon attached to 2 oxygen, each having an alpha group, and a hydrogen, and a propyl group, which is an acetal. Acetals always need 2 OR groups. And a helpful hint Dr. Petrucci would say is that acetals look like a cat. And there you have it.
Okay, now moving to the hydrolysis of acetal mechanism. Well, it's the same mechanism as formation of acetals, but in the opposite direction. See here how we have the acetals. An acid is required as a catalyst, and water is required as a nucleophile, which will attack this carbon and form this carbonyl and the 2 methanols. Let's look at this example. Okay, here we have the acetal. So the oxygen here attacked this hydrogen from the acid, right? And we will form this molecule. Here we have a good leaving group, which is alcohol. So the leaving group leaves, and the lone pair on this oxygen forms a pi bond with this carbon. So we see here the methanol leaving. That will take us to the oxonium ion, where the oxygen has a formal positive charge, making this carbon a good electrophile. So as we said, the water is our nucleophile. Oxygen will attack this carbon, and the pi bond will break. And we'll go to this guy. Here, our conjugate base, which is the sulfuric acid conjugate base, will attack this hydrogen and deprotonate the water. So we'll have a hemiacetal. We want to make this guy a good leaving group, and that's by protonating this oxygen by attacking the hydrogen from the sulfuric acid, breaking this bond. And we'll have a good leaving group, which is alcohol right there, right? So the good leaving group will leave, and the lone pair on the oxygen will form a pi bond. And we'll get here an oxygen with a formal positive charge. The conjugate base of sulfuric acid will attack this hydrogen again and deprotonating this oxygen, and we'll get our products, which are ketone and 2 methanol.
Thank you for watching and hope you were paying attention.